This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Dr. Daniel Chatterjee, the Director, Technology Management and Regulatory Affairs and Head of Green and High Tech Program of Rolls-Royce Power Systems, to discuss the fuel transition in the maritime sector. Dr. Chatterjee, just to start, can you give a brief overview of your responsibilities with Rolls-Royce Power Systems?
Yeah, it's my pleasure. So it's also an honor for me to be a part of that series of talks. Yeah, so at Rolls-Royce, we are part of Rolls-Royce Power Systems. We are part of the Rolls-Royce Group, one of the three divisions, and we are responsible for providing propulsion and power for marine power generation industry applications. So all topics where you need a lot of energy. And my role is I'm leading the Department for Technology and Strategy. So we look forward to have a long-term view and think about what should we start and when should we start about it, and on the other hand, on regulatory issues.
As you know better than I, maritime is embarked on the path towards decarbonization. Can you put in perspective how fuel transition is driving R&D at Rolls-Royce Power Systems today?
I think fuel, or this discussion about fuel and fuel transition, is really one of the key drivers. Because if you just take one example, so one of our engines, 2 megawatts, would run that for 8 hours, and you would need 100 tons of batteries. So I think especially the high power density of the fuel, that's always the key for a lot of transport tasks in the maritime industry. And we believe if we talk about significant decarbonization, we know IMO has 50% announced, and a lot of customers and even governments talk about complete decarbonization, which should be the ultimate goal. And then clearly the decarbonization of the fuel, that becomes the key part. And that's why we have really started to look for projects and really for new energy conversion systems that can be running in engines on completely new fuels like methanol or new technologies like fuel cells. And another thing is how our roadmap is affected, that we believe and will look on the whole ecosystems. So we are in discussion with our customer, what does this mean for your integration of this new fuel or technology into the ship? What is the port structure required, and how is the port influenced, and how can this e-fuel made available in these large quantities, because it will not work out if we think about new energy conversion propulsion systems if there's no way to get to the fuel. So but clearly e-fuels are on the more long term, and so on the short term we also now work on hybridization, gas engines, because we believe these are topics. Gas engines we offer already today, hybrid will within the next few years, so that are topics which can have an impact even today and are future proof, because even with e-fuels you can run those technologies. And I think maybe the most obvious one how we deal with that is that we now have founded a new business unit, Sustainable Solutions, which is really focused on bringing those new sustainable and innovative solutions to the market. And also on the R&D department side, we have now a dedicated department called the Power Lab, who's working on those technologies. Now, I believe that shows also our commitment to that topic.
Looking at the fuel, though, today it's generally agreed that there is no silver bullet solution to get to the emissions reduction mandated by IMO to 2050. Can you describe the process known as Power to X, which effectively is designed to turn electricity into fuel?
Exactly. So it starts really with renewable energy. So that's the source you need. Could be wind, could be photovoltaics to start with CO2 energy. The next thing is you take that energy, and then with electrolyzers you take water and make out of water hydrogen and oxygen. And hydrogen in our terminology is maybe first e-fuel, because you can basically try to run an engine on hydrogen or even a fuel cell. But hydrogen clearly has maybe a third, depend if you have liquid hydrogen of the energy density of diesel. So there's a lot of reasons and also maybe handling to go further, to go to the synthesis process. And then you take CO2, and there are chemical processes like Fischer-Tropsch, where you can make e-diesel, synthetic diesel. You can make methanol out of that. You could also use nitrogen and make ammonia. So then different routes, and so you get different fuels out of that. You may now wonder, okay, why taking again CO2? Because if you burn, for example, that methanol, you have again CO2 in the atmosphere. And the only thing where that makes sense, the trick maybe is to use CO2 from the air, which is called direct air capturing, or from biological sources, which would be another alternative. Because if you take it from biological sources, you have also a circular way of handling the CO2. And maybe I would say in the beginning to ramp up that point sources like cement production, things like that could be another alternative, but this would be more reuse of CO2. And that's basically the process where you need hydrogen. That's the first key, green hydrogen out of electrolysis, and then you can further synthesize that to different fuels. And the main reason is to synthesize handling. Methanol is something we can handle quite easy, more easier than ammonia, and energy density.
Obviously, the derivatives of power to X can result in a number of different fuels, as you just outlined. Today, do you and your team see one fuel emerging as the biggest potential to dominate as the fuel for maritime in the coming decades?
So currently we don't see the just one fuel. And maybe that there will be not really one fuel at all. So that there, even in the future we see there are different fuels. And the reason is just we are in a phase where still elaborate on different technology options. We look on the economics of that and how will that impact integration into the ship. Clearly, e-diesel, that's very attractive because you can use the existing infrastructure, you can address the existing fleet and all that. So we believe therefore e-diesel, so power to X diesel, if you use that term, will play a significant role. And if you go then for, let's say, fuels we don't know that much today, that could be hot candidates are e-methane or e-LNG, because that basically we know we have some, now a maybe emerging trend with LNG in the maritime industry. So that next step would be that synthetic methane, and then methanol and ammonia. I think that there are two more hot candidates. So methanol is kind of a sweet spot. It's the first in the row of synthetic fuels you can make, which is liquid. And ammonia requires no CO2. That makes it attractive. But on the other hand, it's a toxic fuel. And therefore, we don't see it in our applications. So where we have a lot of coastal shipping, passengers on board. So at the moment, we don't believe that that's really the right fuel for that. But for deep sea shipping, where you've trained people on board and you have not continuing coastal contact, that could be, or we believe we will see that. And so these are the hot candidates we see. But in the end, what we need is a stakeholder dialogue. So we'll look on the big picture and to avoid the chicken egg problem.
So just looking again at power to X, what is the realistic timeline to achieve power to X, and what do you see today as the biggest challenge to achieving the full promise of power to X?
So we see as a timeline really 2030 and beyond. That's just because we believe we see there's a high momentum now really to give investment in production. But if you look like lead times of the plants and things like that, and as I mentioned already, that we have still some technology and economics evaluations. So let's say 10 years, that's realistic. And the challenges, the good news is, in principle, the power takes technology is available. We need no basic research on that, but we need industrial upscaling. If you look, for example, in the electrolyzer production today, that's very handmade. So industrial upscaling is the key to get cost and quantities. And clearly we need renewable energy. So just to give an example, just to produce the fuel for aviation and maritime, you need to 150% more renewable energy than we have today. So that's possible if you look which places you can have that, but that's a challenge. It will be key, therefore, to get the countries like they have attractive production capabilities, Chile, Australia, MENA region, to get them really on board, because that's where you can produce the fuel on a good cost base. And clearly, we need on the one hand a clear regulatory framework, so like at the end CO2 targets, because we need a level playing field, and also what we call fuel regulation. So if you think on ammonia, there's like on IMO level, you need to have regulations to handle these fuels.
I know you've touched on some of them, but what tools or resources do you need from science, from industry, from government to effectively achieve decarbonization?
So I think that one of the important tools is really a clear regulatory framework. So now on IMO, there's a discussion now started. So like with efficiency index on those topics, I think that it's really required that you have a level playing field. What we see in aviation, for example, are quotas for fuels. That could be another alternative, just to have a market for those fuel in the start. And because I think that will be basically the foundation that the industry, which we believe is ready. So we from the propulsion side, we're working on the technology, but also from the production side to really start into that journey. Because if you do an investment, you need to have really perspective, and we're talking about investments where you need to have a payback from 20 years. I think for ship owners, it's probably the same. That's the key, to have a clear regulatory framework where we say, okay, that's the target. Because I think one message we need to accept: the fuels will be not cheaper than fossil fuels.